Okay, hi everyone, this is Dan Elliott, and I'm just going to do a quick video going into a bit more detail about how to use Grid2D collections in Niagara in Unreal Engine 5. So really, the first thing you should do is probably go and watch Andreas Glad's video on the same subject. So he's got a video on YouTube which shows how to do the exact same thing. So if you go to videos, and then you can look at Niagara Grid2D Quick Start. So I'm just going to basically do the same video as this and just kind of show my perspective on this. So let's just dive in. I'm going to create a new project. Let's go to games. I'm just going to create a third person, and I'm going to just call this Grid2D. And there's no real difference between using this in Unreal Engine 5 and Unreal Engine 4 right now. You'd use Unreal Engine 4 and the experience will largely be the same. So here we go, just a normal standard project. And let's just hit Control Spacebar to bring up the content browser. And I'll just create a new folder here. And in here, I'm just going to create a new Niagara system. And it'll ask you to create one from a template or from an existing system. I'm just going to create an empty one just to start from a blank slate. And I'm just going to name this ns_grid2d. And let's dive into that. Okay, so by default, let's just rearrange some things here. You'll see you'll have your sort of system here with its properties, but no emitters. So we need to create an emitter. And in effect, an emitter is a self-contained particle system that lives within the system. And you can have multiple emitters. And each emitter sort of is in charge of its own kind of particles and data. So I'm just going to create an empty emitter. And what we'll have right now is an emitter with basically nothing in it. There's no particles being emitted. If we wanted to, we could come and add some particle spawn stuff here. So under the spawning section, you can have a spawn rate, that kind of thing. Let's is the burst section under here. Spawn burst instantaneous, and what that will do is just spawn a constant number of particles. That will just burst 5 particles. But we're not interested in particles, we're interested in Grid2D collections. So let's come to our parameters sort of window, and oops. And right now under our emitter attributes, we have all the kind of standard attributes that get added by the default modules. So these modules are provided by Epic whenever you create a new emitter, and they do things like, you know, track loop durations and loop delays and age and that kind of thing, just to give you the bare minimum of, so that the system kind of just, well, the emitter just works. But what we want to do is use simulation stages to iterate over data interfaces. So there's a lot of words there. What's a simulation stage and what's a data interface? We'll start with data interface first. If we click the little plus button up here, we can add a new attribute to the emitter. An attribute can be anything from like float, bool, int. It's like a single value that's kind of stored with the emitter. And these are things that there's only one of them per emitter. If we were to add particle attributes and we add, say, a float here, then each float would be on each particle. So there's a per particle attribute. But we're not doing particles. We want just like one thing per emitter. And in this case, we're going to be adding a Grid2D collection. So if you just click this little plus button, and then start typing to filter out your choices, then this is the thing that we want. And there's also other types of grids, pressure grid and velocity grid. They're more for, they're kind of specialized versions of sort of grids that are targeted towards doing physical simulation of smoke and fluid, which is something I've been looking into, but use these only when you're kind of using the, well, they're actually made for the strand hair system, but in this case, let's just go with the Grid2D collection. There is a 3D grid as well, which is great for doing 3D simulation or remarching smoke materials, which I've kind of hinted at before. But in this case, we're just going to do a Grid2D collection. And I'm just going to call this Grid2D. So this now lives with the emitter. And you see this little number here, this is 0. That just means that there's nothing really referencing it. There's no module that's kind of dealing with this as an input or that kind of thing. So to actually modify data in this grid, then we need to actually enable simulation stages. And a simulation stage is basically a custom one of these things where instead of Niagara running this, then running this, per emitter, and then running modules over every single particle, what we can have is a custom stage that operates on whatever we want, really. So let's go down to our Emitter Properties, and the first thing we need to do is just change it to GPU Compute Sim. And that means that everything we do is going to take care on the GPU, and it's going to give you a warning to say that the GPU bounds is not set. So what we want to do is make sure that the area we're working with is a fixed space, so that the GPU knows where the sort of simulation space exists. So let's just do this, and I think this corresponds to centimeters in the Unreal world. So we're going from like -1 meter to +1 meter. So kind of like if you can imagine a lower corner of a box going down to the left 1 meter, and then the other one would be kind of 1 meter in the other diagonal. So let's scroll down, and you can kind of see this little hint down here that says simulation stage something. So if you make this kind of come open, hit this little drop down, and we get this enable simulation stages tick box. So let's just tick that on, and now you see this thing pop up over here, which is a little sort of section where we can add simulation stages. So we want to add one. Let's go and add one, and the only option really is just to choose this generic one. So let's just choose a generic one, and you see this added this one here, and it's called it none, and you can change the name over here. So what we're first going to do is just let's fill the grid with some data. So let's call it fill grid. And right now there's nothing actually, there's no modules in this simulation stage. So we haven't actually told it what we want to operate on. So we have this Grid2D up here. We have to say what we want to operate on. So the iteration source, that's this thing here, we're either going to operate on particles, which we don't really have, or we're going to operate on the data interface. And that's what this Grid2D is. It's a data interface. And then we just tell it which one. So why is it not showing up over here? Maybe we need to reset. I know why. It's because we haven't actually set anything. We haven't actually created the Grid2D. We've kind of added this Grid2D thing here, but it hasn't really been initialized. So in the emitter spawn, this is the section that's going to run right when the emitter kind of comes alive, and it's going to happen once for the whole emitter. So what we want to do is kind of set the value of this kind of, this is almost like a reference where we want to actually set what this is. So we could drag it in and drop there, and it's going to set that for us. And you can see that the Grid2D collection comes up here. This is kind of like a local one. There is this render target parameter. That means we can feed in from Blueprint an external render target to use as the kind of the backing storage, I think, for this Grid2D. But we're just going to let the Grid2D take care of its own storage. So we can set the resolution here, and I'm just going to set a resolution of 128, because if you're following this tutorial, then that's probably going to be a reasonable resolution and not going to slow your machine down. And you can also control the data type. So in this case, you can choose half float or a byte, which is like an 8-bit channel. So we're just going to leave it at the default of float. And you can preview it, which will eventually show a preview down here in the preview window. But so for now, we've actually kind of set that, and let's go back to our simulation stage, and we should be able to choose that now. So we have this Grid2D thing here. I haven't quite worked out why there is a second version of it. I remember watching a tutorial or a stream where they talked about this, about how it automatically creates like a version of the attribute that was created right at the beginning, almost like for you to be able to reference the default value. But we want the kind of the main one, the kind of the live one that's being passed through. We have an option here for this to be to operate only when the emitter is reset. This is this little checkbox, and it won't operate kind of per subsequent frames. So it will happen here, but it won't continually update. It will just kind of stay static. Well, not static, but this particular simulation stage won't run after it's run once. So let's just do that first. So how do we actually operate on the data? So let's come into here, and normally we would add a module, that kind of thing. We don't have a module on disk. We could come to the content browser, which you could do here, and we could create a module script. But I like using the scratch pads just because it keeps everything local, and it's great for when you're experimenting. So yeah, if you didn't see what I did there, I just hit the plus button, typed SCR, and it filters down to this list of choices, and you can just choose a new scratchpad module, and it will create this one in place and open up the module in this module editor window. So let's move that down and actually make a bit more space. So here, what this is doing now is in map get, this is going to be where we can actually get channels from the grid. And over here is where we can write channels to the grid. So if there are no actual channels created yet, then we can actually create one by typing in float here. So let's create a new float, and by default it's a local float. So that means that, one second, let me just turn off some notification sounds. Let's just close that, and let's go back to Unreal. This is going to create a local float, which is local to the module. So okay, let's back up a second, because this simulation stage is operating on the Grid2D, and based on its resolution, each one of these sort of modules is going to operate on every single voxel. So this is, in effect, it's a kernel that is going to run the same operations that you run here on each voxel. And okay, so local is a local variable per each kind of thread that's running on each voxel. But we don't want it to be local, because if we're writing, we want this to be written to the grid. So stack context will actually allow you to do this here. So if you allow this to be a stack context, it will allow you to create new variables. And actually, I shouldn't have closed that browser window, because in the 4.26 release notes, there was a reference to stack context, which will kind of explain a little bit more about what it's doing. So added the stack context namespace to allow more reusable modules across different stacks. This also enables data interfaces to be used as iteration sources in sim stages to act like particle namespace and create named attributes on Grid Collection 2D. So I'm still not 100% sure. All I know is that if you use that on the map set in the context of a data interface, it will create that channel for you just by the fact of this being there. So we could come here, and now we can click on this new float, and we can rename this. So the name that you give here is the name of the channel that you're trying to set. And let me have a look at see what other kind of data types we can set. So can we create a new vector 2D? Yeah, we can. So let's create a new vector 2D. I'm going to remove that previous pin. So that will actually take away that channel from the grid now because it's not being set. So let's call this, let's just call this UV. And let's have a look over in the attribute list here. Now when I create apply, actually this needs to be stack context. When I hit apply, you see what happens here? This Grid2D UV sort of attribute appeared. So what this is it gets this additional namespace, which is I think it's a namespace modifier, which is kind of an additional custom thing for you to be able to put your own custom namespaces, and it means you can interpret them in more flexible ways. So this is slightly different than this, I guess, in that this is the actual channel. The Grid2D collection is more of like the container or the manager for the individual channels, and then this is the actual channel itself. So if I set this to be 0.5 and then 0.5, then now we're setting the data in the grid. So now when this runs, it's going to run once and it's going to set the data, but we can't actually see anything yet. So let's have a look at the preview for that to see if it's showing us anything. So there we go. We've got this grid, and this is showing us. Well, it's showing us in red. I'm not sure if it can actually show us in separate colors. So maybe I'll add a new float and make that stack context. And let's create a value of 1 and apply. And we should see an extra channel appear if we resize this. Hopefully we should see something appear. There we go. Okay. Okay, so what it was doing, it's actually created two separate floats for this vector 2D, or it's displaying the vector 2D as just two separate channels. So if I put this to 0.25, not 25, I'll put this to 0.25, then we should see this first one kind of get darker. There we go. So that's the first component of the vector 2D channel, and that's the next component. And basically this is the whole grid. It's 128 by 128, but we're filling the same value in each pixel. So let's do something a bit different. Let's we want to get a unique value for each pixel that kind of gives us an indication about where this current module for this pixel is operating on. So the way that we do that is we actually have to grab the Grid2D, and we have to be able to call functions on it to query some information. So let's create a new Grid2D collection input. And what the input scope does is, I haven't hit apply yet, so you won't see this. But if I come down here to the module, if I hit apply now, what you'll see is a new input appear on the module. It's not hooked up to anything. So what can I do? What can I do? I'll just go through the motions of showing what I was going to do, which is I want to be able to query where we are. So let's type in unit, and what we want to do is call execution index to unit. And what that will do is it will take the execution index, which is a value from 0 all the way up to however many voxels there are. So it's kind of 0, 1, 2, 3, 4, 5, all the way up to 128 squared minus 1. So let's plug this into the UV, and let's see what that gives us in the preview. Let's remove that one. Don't need that anymore. Okay, so it's not exactly showing what I was hoping, but I was hoping for it to give us a gradient. I know why. It's because we haven't actually set the input of the grid. So now we've hit apply, we can see that this input has appeared on the module. So if I disconnect that and hit apply, you see that there's, let's get rid of it. Then this hasn't appeared, but as soon as I connect that in, I guess the compiler kind of compiles that out because it's not being used, but as soon as we hit apply, interesting. Let's try that again, just to make sure that, okay, so it was applying, it's just for some reason. Where's my scratch pad gone? Let's redo that scratch pad because I think I might have accidentally deleted it. So let's create a scratch pad again. New scratch pad module. Let's create a new float. Oh, sorry, new Vector2D. You get to see this again. Lucky you. Okay, new Vector2D. Let's call it UV. Nothing's happened yet, but you saw that little thing pop up there. And we get the preview back. And we want to pass in a Grid2D collection as the input. Now let's hit apply and see if anything happens. Nope, nothing happens. So let's take execution index to unit and pass it into there. Hit apply. Now we get the input to the Scratch module. Oh, when I hit this delete, this deletes the module, not the input. I did actually just go and delete the module. So don't do that. So yeah, we're getting garbage data here. It's not great. So yeah, you'll see that this is kind of creating a new Grid2D collection on the module itself, which we don't want. It's not, we're creating one kind of locally, and that's what it's operating on. Whereas we want to actually override this one that's being input into the module. So let's do that. Let's get the one from over here, this Grid2D, and we can just drag it over. And now we're actually operating on the one from the emitter that was created. And lo and behold, you can see down here that what we're getting is a value from 0 to 1 in this direction, and then 0 to 1 in this direction. And you might be confused why it's going from 0 from the top. It's just because, I guess, whatever API they're using, which is DirectX, or just the way that they've designed it, they consider the origin to be in the top left corner and increase as it goes down. That's just the way that some graphics APIs work. So, okay, so basically all you need to know is that, yeah, it goes from 0 all the way up to some number of voxels that it's operating on. That's the basic idea. So what we want to do is, maybe we want to visualize this on some material now. So what we're going to do next is come back to the emitter, and we're going to add we're going to modify the existing renderer, because right now it's got this kind of particles renderer. So it's rendering a sprite, but by default this sprite renderer renders a sprite for each particle, whereas we just want one sprite for the whole emitter. So by doing that, we can see this is one sprite, and it's kind of taking the emitter itself and acting as if it's a particle. So let's kind of create a new material for this. So if I come to, what's going on? Let's come to our content browser. Let's create a new material. And in here, I'm just going to set this to an emissive material, just because we want to view just the basic colors. So let's just create an unlit, yeah. And let's take in a parameter. So we're going to create a render texture object parameter, or texture sample parameter, that's the one. And let's call this RT for render target. And let's just plug that into the emissive color. So right now, if we save this and then come back into Grid2D and we change that to our new material, which we should have probably renamed it something. Let's go back to our content browser and let's rename this to be Niagara matte. And come back here and we'll choose that one. So now we'll see this material show up, but it will show that kind of default texture. Well, it should do. There we go. Took a while to compile that shader. So what we want to do now is we need a way to feed this data to that material. And to do that, we use render targets. And the nice thing about Niagara is that it can actually create render targets as well. So if I come over here, I can add one. Niagara, not Niagara, render target 2D. So let's call this render T. And to operate on this, we're going to create a new simulation stage. Now you might be wondering, why don't we create it here in this fill grid? A couple of reasons. One is that, well, it's nice to kind of separate out your different operations into different simulation stages, just for readability reasons. But also, I think that there's something to do with, you want all of the writes and the operations for this simulation stage to finish before you start the next one. And also, the data that you're iterating on might be different. So in this case, we're going to create a render target, which is going to be the same resolution, but we might want to change that resolution later on. So we want the simulation stage to have a different kind of iteration count. So let's set our value here, and let's create the same resolution. And one thing I have seen in some of the Epic inbuilt stuff is that you can create the emitter or you can create the render target and the grids. You don't have to set the resolution right away. You can actually have separate modules that go in, change the resolution after creation, which might be handy for some reason. You can change the type, so this could be a red 8-bit channel or RGB 8-bit channel. I'm going to go for red-green 32-bit. So this is going to be 2 channels, 32-bit float. So that's what we want. And there is an ability to pass in a render target, which is created externally in blueprints or an actual asset and passed in. But in this case, we want Niagara to kind of manage it again. So let's create a new simulation stage to operate on this render target. And let's call this fill RT. And we're going to choose data interface. And in this case, we're not operating over the Grid2D. We're going to operate on the render target. How am I doing for time? Yeah, not too bad. Okay, so we're going to want to create another scratch pad. And in here, we are operating on our render target, but instead of writing to the map to set channels and create channels in the render target, there's only one channel really, or there's the 2 that we've set. We want to set the value in the render target, and the way that we do that is with a function. So you can either just call set and see if it comes up, but if it doesn't show up, then what am I trying to say? Yeah, I think we need to pass it in again as an input. That's one thing I've kind of wanted, is ability to right click and create a node that just says this, and it will reference the current data interface that this module is operating on, and that means you wouldn't have to pass it in as an input. So let's just hit apply. Does it pop up yet? No, we need to actually do something with it. So drag off here, and if you just come down to under this section, you'll see there's only 4 things we can actually do with this grid, and one of them is set render target value. We wouldn't want to set the render target size in a module in a running in the simulation stage. We might want to set the size up here, and that would mean that we're not setting it using the properties kind of editor. We'd be doing it inside a module, but it's only run once, either on spawn or update. So let's no, we don't want the size, we want the value. So render target, set render target value. And now you'll notice that this is not the same as setting a channel on the map set. So we're not writing to a channel individually. We're calling this node, which is going to do the same thing effectively, but it's just a slightly different way of working. So we don't actually need that map set, so we can delete it and just make sure that your execution pin is connected. And what this does is it takes the current index of where we want to set the value. So let's get that index. So render target linear to index. So this is very similar to the kind of execution to unit, but instead of getting unit, which is 0 to 1, like a UV normalized value, what we're getting is integer coordinates of the x and y of the grid, or of the render target, and it takes in that linear as input. So this maps from that sort of execution unit that the underlying hardware is kind of keeping track of, which we don't really need to know. I mean, we could use this for things like seeding random values and that kind of thing, but in this case we're just interested in the kind of the current grid coordinate. So if we let's do something here. Let's get the resolution of this grid. So if I pull up another pen, come here and say get render target size, this is going to give us those values that we set up here. So we can get that size and divide it by there. So let's do that, and we'll copy this. And this is effectively going to do the same thing as what we did with the... This is basically creating that kind of unit. Sorry, we're not putting it into the index. Ignore that. Don't do that. What we're doing is we're going to make a new vector here. So make a vector 2D. I think we might need to do it here. Yeah, make vector 2D. Let's create this new one, and then we'll feed it in there, and then we want to set the where we're going to be setting that value. So you might notice that it's created this new intermediate node, and that's because for some reason this just takes in a linear color value, which is just a different data type. But it has to convert that. We're going to take those indexes and put them in there to tell it that this is the current one. And that's the thing, you could actually set a different voxel from the current module, which is operating technically on a different execution index, but you got to be really careful that you're not writing into the same voxel from multiple locations, because you'll get race conditions. So that technically should be writing into the grid. So if I come over here, let's turn this preview off, and can we preview this one? Okay, so we're not seeing it because, are we not setting it on here? Let's see if that makes a difference. There we go. So you can see now that we're actually filling in data, and this is actually color. That's quite nice. Let's hide that little display. And I have my divides wrong. Let's go the brute force way. And finally, we get what we want. So yeah, basically, if we, first of all, put the actual current index in the numerator, that will do what we want. I always get confused, but we got there in the end. And if we force one of them to be float, then it will promote the other one to kind of match that floating point. Okay, so there we see kind of the standard kind of 0 to 1 color mixing that you normally see. And this is being written to the render target. And I'll point out, everything we did in the fill grid, we're not seeing the effect of that yet. Let's first of all deal with passing it through to the material. So in our sprite renderer, down, if you come to bindings, this is where we feed stuff to the material. And if you click this add, then it knows how to kind of communicate with the material. And under here, under material parameter name, it's exposed that RT thing that we created. That's kind of shown, and it's kind of visible to Niagara. And we can click on that, and it's telling us what do we want to set as that variable. So we're going to choose the render target as the variable, and now instantly you can kind of see that it's set that. And I've noticed that there is some weird rendering with the kind of the sprite or the texture rendering, where it will grab like some of the last pixels. There's like a wraparound thing going on somewhere. So I'm not sure if that's due to an issue with the texture. Or the render target. Maybe it's an issue, something with the render target that we can set. It's not available here, but maybe it's available if we were using an external asset. But you know, it doesn't really matter. We're just experimenting here. So how do we? Yeah, this is only going from this scratch pad, this scratch module, to the grid and out to the material. We actually want to sample the grid values that we set before. So let's just get rid of everything that we created. This was just for educational purposes. So let's just disconnect those, and I'll disconnect those. So how do we get values from the grid? Well, we're operating over the render target. And actually, I realize we probably need these. I'm going to take these back because we'll use those as sampling locations. We want to input something to this module. So let's input that Grid2D. And again, we'll keep it as a Grid2D collection. And you see again, it's created it up here, but it's created a local one. We want to set that one. We want to override it with the one from our actual emitter. So we'll drag over and we'll set that. So now we can actually pull data from this. So let's now you can kind of see there's this little like one voxel that's being set up in the corner. Bit hard to see. For some reason it's yellow, but I think that's just because it's setting the 0, 0 voxel multiple times, and it's, yeah, don't know what's going on there. It's kind of bugging out. But yeah, let's deal with this Grid2D collection. So let's do this, and under our Grid2D collection, there's a lot of functions we can choose from. That's what makes Grid2Ds kind of nice to work with, because they're quite flexible. But what we're going to do is we're going to get previous vector 2D value. So let's do that, and we need. Okay, so there's two different nodes on the Grid2D collection. There's get previous value, and there's also sample previous value. And these are they both are responsible for getting values from a grid. But you'll notice that with one of them, it takes an integer index, and that would be like the whole kind of integer location of a single voxel, and you'll get like the whole value. Whereas what sample does is you give it a unit position, which is a floating point kind of location within the grid, which is in between voxels. And what it will do is it will interpolate between those voxels. So here we could pass 0.5, 0.5, and it will get halfway between the voxels, basically. So depending on whether your render target is the same resolution as the fill grid, as your Grid2D, then you can choose to do different things. If they're the same resolution, you can use the same index to sample the exact same location as your render target. But if your render target is a higher resolution or even lower, then you're able to take this kind of position, this kind of smooth position, and use it to sample. And it's taken linear color, Let's just choose this output of this make vector. There we go, because we don't need to output a linear color, just a sample. Okay, and we need to choose which attribute we want to sample. So we called it UV, I think. And let's get rid of that one for now. Actually, I'll keep it around because I'll show how it can be used for the same effect in this case. So let's write the value. In this case, it does need to convert to linear color. And we are going to set the index. So here we go, let's hit apply. And magically, this is actually taking the value from the grid. This is no longer using this UV kind of texture coordinate value to set the value of the render target. We're using this UV value to sample the UV value that we created before. If that's confusing and a bit Inception, then yeah, I can completely understand that. But basically, we're creating this UV value with this thing, writing it to there, and then we're manually creating that UV value, the same thing, resampling in that location to get the same value, and then we're writing it to there. So you might be asking, why am I doing this? It's like, well, it's just to show you the mechanics of how it all works. But then we're going to go back in a minute and we're going to change some things about what this is doing. So just for a second, I'll also show you this get value. So because these are the same resolution, I'll show you the effect of us sampling the same location. So I'm just passing in the linear index and we're going to get the same location of the grid. So what we're doing now is we're taking the current position in the render target and we're looking up the same location in the grid, and we're going to sample that channel, and we'll write the value, and we should see the same thing. Yep, there we go. So I'll get rid of that because I want to use this for now. Okay, so where can we go from here? We know how to write stuff into a grid. We know how to write stuff into a render texture. Let's do something like what I was doing in a fluid simulation where I wanted to create a pattern procedurally in the grid. So what we'll do here is we'll take this execution to unit and let's subtract a value from it. So I'm just going to pull off a pin, come to this numeric, I'll just type subtract and hit enter. And what I want to do is take this 0, 0 value and effectively move it to the center. So we're not really moving anything. What we're doing really is we're taking this center, which is 0.5, 0.5, and if we subtract 0.5 from it, I know that this is actually a float, but it will promote to a Vector2D. This will get duplicated into two components. We're subtracting 0.5, 0.5 from here, which this will now become 0, 0. 1, 1 will become 0.5, 0.5. And then here will become 0, 0. So what we're doing is we're kind of effectively kind of shifting everything up by subtracting. I know it's backwards, but I did make a video on UV manipulation, which I'll make a link for, and you can click on that and have a look. But when you come to UVs, you kind of have to like do the opposite to get what you want. You have to subtract to move the UVs forward. So I can actually show that visually. If I write that to the grid now, what you'll see is that everything's been shifted. So before, the 1, 1, which was kind of here, has now become out here somewhere. Well, it's not really there, it doesn't actually exist, but the values have all been shifted by that amount. So now we have this kind of centered position where 0, 0 is in the center. And that's useful for us because we can use the values that are in the grid. We can use the values that are coming out of this pin to do something procedurally. So I'm wondering if I should normalize this to make it, because this is negative 0.5 and this is plus 0.5. So what I probably want to do is multiply it by 2. And what that'll do is it'll make it go from -1 to 1. And everything will get brighter. So we're going from -1, -1, and then +1, +1. And this is like +1, 0, and this is like 0, +1, with 0, 0 still in the middle. So what can we do with this? Well, now we have this kind of like grid coordinate system, which is basically kind of like if you imagine a graph where we have X and Y. And if you take any position within the graph, then we can get its distance from the center by taking the length function. So let's create length. So you can imagine that this is a bunch of vectors in space, where here represents the vector 1, 1, where it's an arrow pointing from there to there, and this is the vector 1, 0, it's an arrow pointing there to there. So let's take the length, and you'll see what happens if I plug this in. What we'll get is this kind of like gradient that kind of spreads out from the center. So it's the distance from the center to the center is 0, and it kind of gets larger as it spreads out. And the reason it's yellow is because we're only dealing with the red and green channels. If we had a blue in there, it would become white, but you know, red plus green gives you kind of yellow in this case. So what can we do with this length? Well, we can basically compare the value with some user-defined threshold. So if we do an if, then we want some condition, and what condition do we want to check? Well, we can choose less than or less than or equal. Let's try less than or equal. And we want to compare this value with, well, if we compared it with 0, then the center would become true, but nothing else would. If we compared it with 0.5, then everything up to 0.5 would be less than it, and it would become true. So all of these ones in the center would be true, and everything outside would be 0. So let's try some floating point value, and I'm just going to choose 0.5 as our choice, and let's plug in this to our condition. And this if node allows us to create some options about what we want to happen. Is that right? Okay, yeah, so what you have to do with an if, let me do that again, is by default it doesn't actually have anything to choose as the options. What you have to do is you have to choose the output type. So when you choose the output type, then what it would do is it will give you 2 choices for input as well, based on those conditions. So if it's true, I want it to output a value of 1, and if it's float, then I want it to output a value of, sorry, if it's false, I want it to output a value of 0. So if I use this now and plug it into here, what's happening is we're getting a single float value, and it's converting it into a vector 2D. Whereas in this case, I'll just kind of shove this in there, that you wouldn't want to write this to a vector 2D channel. You would want to write this to a float channel just for storage reasons. But it's going to display as a yellow circle because it's a vector 2D channel. So now you would want to go and change the type of this, or you want to remove it and change the type. Okay, let's do that. Let's remove this just so you can see like how you would manage just dealing with data. So let's remove the pin, add a float, and let's do what I was doing in simulation land and just call this density. Maybe this is some source of density that you're putting into some kind of simulation. Okay, so that's that context, and there. Come on. Because it's a float, then we can just take that and plug it in there and apply. So now we're going to have to go into the render target, and we're going to have to change this to sample float. So our render target, remember we created a red and green channel. So now we might want this to be a single red 32-bit float. And just to be clear, we're going to delete this sample vector 2D because now we want to sample a float. So let's go in here and sample a float value, and we're going to choose that same location. So this 2D stuff, this is still dealing with our location within the grid of where we're sampling, and it's still kind of agnostic of the resolution of the grid. You probably want it to be the same resolution, otherwise you're going to get some aliasing issues where you're kind of like undersampling or oversampling even. So if you are kind of sampling a different resolution, you might want to have some strategy for filtering or that kind of thing. So now we can connect that to the set render target value, and it's going to do the same thing. It still needs a linear color conversion, but that's always going to happen. We haven't actually told it what channel we want to sample from. It's always important. I've done that before where I forget to do that and I spend 10 minutes wondering what's going on. One little thing is that when you change the text here, it doesn't mark the module as dirty. So what you can do is just disconnect something and reapply it. And now what we should see is we're seeing a red circle because it's a red render target. And if you wanted to see it white, you'd probably just use that. Would that do it? I'm hoping that just because we're using the red channel, that's going to turn up white now. Taking its time, compiling the shader. There we go. Yeah, so that's good. What else could I show you? I could show maybe sampling a texture, which is something that Andreas Glad did as well, which is... yeah, let's do it quickly. So we'll create a new simulation stage, and let's call this like advection. Operate over the Grid2D, and we're going to drag this up to be before the render target. So we fill once, and then we advect. And in this case, maybe I'll leave it operating on every single frame so we can see some movement. So let's create a new scratchpad module. And that's all happening. We still need to add it as an input because we want to sample some functions on it. And we'll grab it from here. We're going to write to the density channel as well. So we're going to source from the density channel. And we're going to write to the density channel. I always do that. Sometimes it shows up, but I think it only shows up if it's on the input as well. So let's change the namespace to stack context. If you come here and start typing, do we see it here? No, you saw the new float, but we need to tell it that we're operating on density. There we go. For some reason, yeah, channels won't show up until it kind of compiles properly and it knows how to kind of introspect onto the channels. But yeah, what we're going to do is maybe it's good that I showed you this because it shows you how you can grab channels from the current data interface. So this is operating on the Grid2D, and the map-get can actually access the channels as well. You don't have to sample a value or get the value using a node. You can actually get the current value of the current voxel that the module is operating on from here. And if you just connected it, it would be a pass-through. But in this case, we're going to be Actually, we're not actually going to be using this. So, sorry I showed you that, but it's good to show you. Remove pin. We're actually going to be getting a value, and let's use the function. We want sample previous grid float value, and we're going to be giving it a position, and the position that we want is some kind of offset. So let's sample a texture to get some random vector. I'm just wondering if there's any noise functions. No, it's a curl noise. It's designed for simulations, so I'm guessing that's not what we want. And I think that noise is a random noise. Yeah, it's not a Perlin noise or anything like that. So let's what textures do we have? Probably not many from the starter content, because I don't think it comes with any. I might have to import one. There's probably some in the engine content somewhere. Let's just go and try. Okay, so what we're going to need is some way to sample a texture, and the way that we do that is with a which one do we want? Texture sample. Yeah, 2D array textures they're textures with multiple layers. We don't want that one. We want just a normal texture sample. So this new texture sample, and I guess you could create these as attributes, but we want to use one local to this grid. So does it come onto here yet? Nope. Let's connect this up so that we are actually setting a value, and hopefully, so for some reason, if you don't actually have anything connected up, it doesn't do everything all the time straight away, but yeah, it's showing up now. So we want to pass over our Grid2D collection, and our texture sample, we're just going to be using the one that's created by default on the module itself. So we're not inputting one, we're not overriding this one, we're just kind of using the one that's here. And in terms of texture, let's have a look for noise. There we go. Game wind noise. That sounds like something we want. Game wind noise. Okay. So where are we currently? Let's get our execution to unit again. So this gives us where we are from 0 to 1. And if you know anything about textures, then you know that they like to be sampled in the 0 to 1 UV space. So let's see what functions are available to us from the texture sample sort of functionality. And texture sample texture 2D sounds like what we want. Yeah. So that will take a UV, which luckily our unit effectively is a UV. So if we can't plug this directly into the unit because these are like random values, and that will just kind of jump to the position in the texture. What we really want is to take the current position, and we want to offset it. So we're going to subtract that value. So that'll take the current position, sample the vector, and then we're going to subtract from the current position, which will offset it by that value. And that just kind of takes a value and moves it off to the side. And I'll just do this so you'll see what it looks like. And straight off the bat, it's going to look a bit weird. Anything happening? Do I have an error? Is it a problem with this module? Is it a problem with shaders compiling? We have an error, but I've noticed that Unreal Engine 5 doesn't show errors as much as Unreal Engine 4. Why has particle spawn got an error? Okay, I'm going to pause the video and see what's going wrong. Okay, so I've had to think about it. I haven't actually verified this, but I think it's because we got a 2D value, but it's sampled a vector 4 value. So we want to basically break this into kind of a vector 2D. So break vector 4, we'll break it into 4 separate components, and then we want to make a vector 2D from that. So a little bit annoying sometimes that you have to do this kind of stuff and that it's not auto, but I'm pretty sure that as Niagara matures, then these kind of things will be added. So let's plug that into there. And now, fingers crossed, any second now. It's compiling. Okay, so it's not an error. That's good. What does it look like? Let's try a little experiment. If I multiply this to 0 and we subtract nothing, what do we get? Okay, and if I add a little bit of a value to that, what do we get? There we go. So the reason is that it was just too strong and that it was offsetting in some really big value and instantly kind of sampling off to the screen. I'll just hide that. And now you can see that it's well, it's doing something. It's advecting down and to the right, and that's because it's kind of going in the positive direction. Every one of these values in the texture is from 0 to 1, so it's basically advecting in the positive direction. So how do we fix that? Well, we can just remap these values. So if we take this vector 2D and we subtract 0.5 again, we're doing the same thing as we did before with the centering of the UV value kind of grid, and then multiply it by 2. Let's do that. Apply, and that should take our 0 to 1 and make it negative 1 to 1. So it should kind of like move it in all directions, and it should be a bit more random. There you go. But because it's fixed, all of the kind of values are being pulled into the same areas. So we probably want to change where we're sampling from. So here, where we're taking the current unit and where we're choosing to sample the UV, we can kind of interject here and add some kind of panning effect. So up in the map get, you don't just input grids and texture sample nodes here. You can actually get emitter properties or system properties such as the age or the current delta time, that kind of thing. So let's get the age and get the emitter age, and let's make a vector 2D. And what I'll do is I'll just create some kind of random direction, and I'm going to go negative because, like I said, it's well, for X I'm just going to do like a little tiny amount, and then for Y be negative because we want it to have that kind of backwards effect. So if we multiply this by age, now what we're going to get is we're going to get this vector kind of increasing in size in that direction, and it'll act like an offset to this kind of where we're sampling. So all we have to do is just add those two things together. So that will move the noise, and effectively every frame we're going to get some kind of different sampling. So you can kind of see how it's going down. Oops. Let's maybe make this, maybe that's way too fast. Wanted that to be negative. So you can play with this, you can kind of change what you want it to do. For some reason it's kind of stopping what it's doing. I thought it would wrap. Oh well, I'm just kind of playing around here, and it's very late, so I would suggest have a play yourself and see what it does. The other thing I would say maybe is we're subtracting this kind of we're subtracting this vector 2D by this 0.01. Now what we really want is for this to be based on delta time, because if you've got a really fast card and it's running at 100 FPS, then you're going to be doing this constant amount every time, and it's going to move this stuff in the grid much faster. Whereas if you're running at 20 FPS, it's going to be doing less of them, so it moves slower. So let's actually get the delta time from the map as well. So let's get, and we'll plug that into this multiplier, and we might want to add an extra sort of multiplier on top, just to give us the ability to boost it if we want to. And instead of having it here on the node, what we could do is add our own user. So if we do a float and make it an input, and call this like advection strength, then if we hit apply, then on the module we get this new advection strength parameter that shows up, and that's how you kind of expose things to people using the module without having to dive in. So let's get that advection strength, hook it up to this delta time multiplier, and we'll use that instead as the multiplier. So okay, so in this case I do want it to go upwards. Because we're subtracting, we want it to do the opposite of that, so we want it to go up, because maybe we're doing some kind of smoke thing. Yeah, I'd really like to know why that is kind of, maybe it's set to some kind of clamp mode. It's very weird. It must be. Oh well. What happens if we set it back to 1.1? Okay, so it's doing that, but yeah, I don't know why it's I need some way to visualize this. I haven't actually practiced this properly before. I just turned on the recording and I'm just rambling basically. I guess it's still moving, kind of. I guess it's just, yeah, moving constantly. We might want to rotate this or something. Do we have a rotate rotate vector 2D? We might want to do that thing where we get the unit rotate it around time by time. So let's get our age, and maybe we use that, and it will be rotating around. Maybe we probably are going to want to multiply down that age so that it's not so fast, but now at least what we're doing is taking the source UV coordinates, and that gives us a lot more kind of randomness. Yeah, probably want to multiply that down. Let's just stick in some hard-coded value here. Try 0.2. Let's see what that does. And we'll try something a bit faster here on the vertical. Let's see what we get. One thing is if you are using the timeline to kind of see the effects of something, if you come down here and change this to the lowest, then it's quicker to get to that point. You can kind of see how it's rotating there. So it's rotating and then adding. Maybe what we want to add and then rotate. Let's add and then rotate that and add it to the texture sample. We're still using the original unit index as our sample position from what we're subtracting from, but our where we're sampling the texture is changing now. Looks a bit weird. Let's multiply that down and multiply this up. So yeah, I don't really know what kind of effect I'm going for here, but maybe yeah, you can have a play. I'm just messing around really. So I don't know, hopefully you've seen like in more detail about how you can use this stuff to do what you want. There's more I could probably go into about iterations. Basically, if you, I'll explain quickly that if you can run these whole simulation stages multiple times. So if you have a few modules and you increase this iterations, it will run them that many times. So that's quite useful for doing fluid solves. And yeah, I'll probably just stop the recording. If you have managed to watch this whole video the whole way, well done. I'm just making these for myself really. I think they're quite fun. And if you enjoy them too, then great. I just really like sharing this stuff, and I like chatting with people in the comment section. And I think that all this stuff is really cool. I think Niagara is amazing, and it's really going to help people who aren't coding all the time to pick this stuff up and start playing with it. I think it's great. So yeah, thank you for watching, and I will hopefully see you soon.